All right, gentlemen, this is the last lecture for Chapter 11. Chapter 11 has been all about water as a natural resource, and this section, Section 3 of Chapter 11, specifically looks at water pollution. So again, we have these initial slides here that just give us a list of the different topics. We'll see these. We'll go through each one of these in turn. As you take a look at the objectives, I want you to note the questions carefully, make sure that you understand and can answer them in terms of your studying for the test as well as studying for the quiz, the oral quiz, which you will have this Thursday morning. From here on out, this is a normal week. All right, so let's take a look at water pollution. And if we were to define water pollution, the way we would define this is to refer to it as the introduction into water, and the water we're talking about here is usable water, in particular usually groundwater, lakes, rivers, streams, oceans. The introduction into water of waste matter, also chemicals that can be harmful to organisms that live in the water, or that can be harmful to organisms that drink the water or are exposed to the water. And one of the things that is important to keep in mind, that the ways that we use water as humans, and this is a natural resource, can all be ways that contribute to the pollution of water. And so we're going to work through some of that and see how we define the pollution and see where we view the pollution coming from. What we tend to see in terms of human activity is industrialization and population growth. What I want you to recognize, in my opinion, when we talk about industrialization being a main underlying cause of water pollution and rapid human population growth being an underlying cause, these tend to be points on a spectrum. And so when we talk about industrialization, we talk about a point on a historical map of when industrialization was taking place unchecked. There was not as much knowledge and it was causing pollution. I don't think it is necessarily accurate to say that industrialized nations today and how they use their infrastructure and how they use their industrialization are necessarily and automatically a point of water pollution. Same thing with rapid human population growth. This has more to do with specific locations. If you have a small amount of people in an area and all of a sudden, for a particular reason, a large amount of people end up in that area, you end up with a regional issue with water pollution, very often because the infrastructure is not able to handle that increased population in that short period of time. So I want to make sure that you're thinking about those as causes of water pollution accurately. Developed countries, as I alluded to, those that are industrialized really do a pretty good job as modern developed countries in terms of water pollution and cleaning up and having different methods of using their industrial capabilities without polluting water sources. Water pollution really tends to be a bigger problem in developing parts of the world because they end up having one source of water. So the source that is their source for drinking is also their source for sewage, and it's also their source for agriculture. Again, they're not industrialized. They don't have the machinery, the infrastructure, the ability to dig wells down into the groundwater. And so they're using the surface water for everything, and they're using the river to drink and to cook and to bathe, but they're also using the river to get rid of their sewage and to wash their laundry, so on and so forth. So really, we're looking at two different animals here. And we talk about the sources of water pollution being a point source or a non-point source, and we'll go into those in more detail. All right, so our first discussion of water pollution is what we call point source pollution. And for you guys to think about point source pollution, what you need to think about is a single point, okay, for the source of the pollution. So if you think about you've got a river and there's a factory that has dumped into the river. That's a single point that is sourcing the pollution into that river. You know, these can be wastewater treatment plants that have something go through them that doesn't get treated and it gets dumped into the creek. These can be an oil tanker that's leaking. You know, it's really a point source pollution is really a single point where the pollution comes from. So it's by definition pollution discharged from a single source. What's interesting about point source pollution is that it's really easy usually to identify and trace the pollution back to that source. The bad side of that is sometimes it can be very, very hard to enforce cleanup. So something to keep in mind. We also have non-point source pollution. This is pollution that comes from many sources rather than from a single specific site. So think about you're in a city and you have major precipitation, major rain event, and there's lots and lots and lots of runoff because your city is all hardscape, and that runoff works its way into the streams and the rivers, goes from the streets to the storm sewers, and along the way it's collecting stuff. It may be collecting petroleum products from the streets, it may be collecting garbage, whatever it's collecting all this stuff. It's not coming from one single site. Okay? It's not coming from one single source, and it's being collected and working its way into the water in that area. And so the accumulation of small amounts of water pollution from many sources is non-point source, and it is a major pollution problem. When we talk about oil spills, you know, everybody thinks in terms of the oil tanker. Everybody thinks in terms of the oil rig, you know, exploding. You know, think of BP in the Gulf of Mexico. But much more oil is put into the environment just from everyday use, from the vehicles that we drive on the roads that leave petroleum products in the middle of the road, and it rains and it gets washed down, you know, into the water system. So that's something to keep in mind in terms of non-point source pollution versus point source pollution. You know, how do you control non-point source pollution? The challenge with non-point source pollution is that you know, it comes from a lot of different sites. It comes from a lot of different places. It's not necessarily easy to track back to a single spot, but public awareness and education, you know, use of products and how they're used and when they're used, all that in terms of awareness and education can actually sometimes be easier to maintain than if you have a major accident, or how do you enforce cleanup with a major accident. These charts, which are in your textbook, basically lay out for us some point source pollution versus some non-point source pollution. So you can take a look at these in more detail in your book. And then this list gives us the principal water pollutants, the things that are issues and why they are issues, from pathogens to organic matter, chemicals, both organic and inorganic, heavy metals, and physical agents. Let's talk about wastewater, because as humans, we're using water constantly, but our use of water also creates wastewater. To think about wastewater, what you need to do is think about the water that goes down the drain. Okay? What goes down the drain in the sink, what gets flushed, the drain in the tub or the shower. Okay? This water may be considered gray water, may be considered black water. Certainly not fresh, potable water after it's been used. And it doesn't just go away. It flows through a series of sewage pipes, and those sewage pipes don't just collect wastewater from you, but from the whole community, the city, town, and eventually these are flowing to a wastewater treatment plant somewhere. FUMA is a big enough school and institution that it has its own wastewater treatment plant. So all the water at FUMA that goes into drains goes into our own wastewater treatment plant, which is then treated. Wastewater, by definition, is the water that contains wastes from homes or industry. Basically, it's water that contains wastes from humans' use of water. And then what happens at the wastewater treatment plant is the water gets filtered and goes through various treatment processes to basically clean it up, make it clean enough to go back into the river, back into the lake. That is what the goal is of wastewater treatment. So how is this done? Number one, a lot of the wastes that end up in the water from homes, from residential use, are actually biodegradable materials, and they're very organic in a chemistry sense, and therefore they can be broken down by living organisms. So, in terms of what goes down the toilet, what goes down kitchen sinks, lots of animal and plant wastes, papers and soaps, all of those are biodegradable. Now, how are they going to be biodegraded? Usually, in terms of modern wastewater treatment, there are microorganisms that we maintain in order to basically decompose or eat those products that I just mentioned. We do have a challenge, though, with household and industrial water, stormwater runoff. There can be toxic substances, there can be heavy metals, there can be things in the water that cannot be removed by standard treatment, things that are not going to be able to be removed by microorganisms decomposing them. This diagram, which is in your book, shows in a very simplified manner what is going to happen in wastewater treatment. The first treatment is going to be filtration, large screens to remove solid objects, which eventually have to be collected and cleaned out, and then a settling tank where the water sits in this tank, and a lot of the solids and particles will settle down to the bottom and can be removed as sludge. And that's the first stage of treatment. Secondary treatment is an aeration tank where there's lots of oxygen. The oxygen is there in order to help the bacteria to survive. You're basically going to be dealing with aerobic bacteria and other microorganisms, and they're going to be there to feed on the wastes. That's what they're going to do. And then there's another settling tank where any sludge, any solids that are left are going to be settled out. And then finally, the water is going to be chlorinated to disinfect it, to kill any remaining bacteria. In particular, the fecal coliform bacteria is the E. coli, and then that water is then going to be considered safe to be dumped back into the lake or the stream or the ocean or the river, whatever the case may be, depending on where the wastewater treatment plant has been set up. What is that sludge that we mentioned and we talked about in a couple different phases of treatment? We call this sewage sludge, and it's actually a byproduct of wastewater treatment. It's the solid materials that remain after treatment. That doesn't just go away. Okay, so you have this process, and certainly the water that goes in ends up being clean water that comes out. But part of the process of cleaning it is getting rid of these solids, and those solids are the sewage sludge, and that accumulates over time. Some sludge contains toxic chemicals, okay? And if that's the case, if you're treating water that has that kind of stuff in it, that sludge is deemed hazardous waste, and it needs to be treated as such, and it needs to be disposed of as if it's hazardous waste. It can be incinerated, and then usually what happens once it's incinerated, the ash that's left over is buried in a landfill. Because of this, sludge can be quite a expense for municipalities. There's a tremendous volume of sludge that is created and needs to be disposed of every year. Think of your big cities and think about the sewage treatment that's going on connected to those big cities. But there's other ways to look at the sewage sludge and what we do with the sewage sludge and how we deal with the sewage sludge. And if there's little to no toxicity, if the toxicity can be reduced, if we don't have to treat this sludge as biohazardous waste, then it can actually be used as fertilizer and is quite good as a fertilizer. There's other processes out there that take this sludge and combine it with clay and actually make bricks out of it, and those bricks are used as a building material. We also have what we call eutrophication and artificial eutrophication. And what's going on here is we're looking at water and the organic matter in water and the nutrients. In most bodies of water, nutrients come from organic matter. So you have leaves, you have animal waste, you even have dead animals that end up being broken down into their component minerals and nutrients, and decomposers, bacteria and fungi do this, and then it creates this nutrient-rich water. And the nutrients that are created in this natural process are very, very important to the ecosystem.
That bird song, so you report to the guidance office?
The ecosystem of that pond or that lake or that stream or that river. But what happens is there can be situations that exist where lakes or streams, especially slow moving, end up building up a abundance of nutrients, and we call these eutrophic. So we have eutrophication is a natural process, this buildup of these nutrients from organic waste. But when organic matter builds up in a body of water in large degrees, it decays and it decomposes. If there's a lot of that organic matter that is being decomposed, more than what would be considered natural or normal at any given time, the process of decomposition, so think about the bacteria and the fungi that are doing the decomposition, the process of decomposition actually uses up oxygen. And what we find is that the oxygen levels get lower and lower. As the oxygen levels get lower and lower, you have organisms that cannot survive under that set of circumstances. And you have fish kills and other animals that end up dying. What happens is the organisms that live in the water, the actual ecosystem has to change over time because of this eutrophication and this using up of the oxygen. So plants, example would be plants taking root in nutrient-rich soil. More plants grow, the shallow waters begin to fill in, the body of water becomes a swamp and a marsh, and you can go in a pretty quick period of time from a deep lake to a bog or a marsh because of this happening. Now, this eutrophication process, remember this whole topic is artificial, it's actually accelerated when inorganic plant nutrients, so fertilizers that contain phosphorus, fertilizers that contain nitrogen, actually enter the water from sewage or enter the water as agricultural runoff. And that is just artificially increasing those nutrients that we were talking about that will be in that body of water through natural decomposition. And this is why we call it artificial eutrophication. And we define it as the process that increases the amount of nutrients in a body of water through human activities, so waste disposal, land drainage, agricultural runoff. And it has effects in terms of biodiversity and in terms of changing the ecosystem. And again, fertilizer and laundry detergents that contain phosphates as far as we understand right now, are the two main causes of eutrophication in bodies of water. You're actually learning about this, guys, as you do your soil analysis. Phosphorus is a plant nutrient. We are testing our soil to make sure it has enough so that people can grow the plants and grow them the way they want to. But in a body of water, it can actually cause an excessive growth of algae. When there's a boom of algae growth because of increased phosphorus, we call this an algal bloom, and it creates these large floating mats. These can actually be seen by satellites in outer space when they happen. That's how large they are. And what happens is the algae die, they decompose. The process of decomposition uses up most of the oxygen, and fish and other organisms suffocate in the oxygen depleted water. Another type, excuse me, another type of water pollution that we talk about is thermal pollution. And we define this as a temperature increase in a body of water that is caused by human activity that has harmful effect on water quality and on the ability of that body of water to support life. Very often we see thermal pollution connected to a body of water when that body of water is connected to power plants or other manufacturing industries that specifically use the water in their cooling systems. We've already mentioned that power plants use water for their cooling systems, and there are other manufacturing industries that do the same thing. And in terms of how they cool their mechanism or their machinery or whatever it is they're cooling, part of that process then involves the discharging of warm water, warmer than the ambient temperature or what the temperature of that water would be in the environment at that time, into the body of water, into the lake or river. And what happens is you end up creating this hot spot in the lake. Over time, the lake or river, its overall temperature goes up. This can cause fish kills. If we understand our gas laws in chemistry, we understand that colder water holds more oxygen. It's going to hold more gas. More gas can be dissolved in colder water. And so if you warm up the water, you warm it up too much, eventually the water doesn't hold enough oxygen to support the life in that water. And that's one of the reasons why you would have the fish kill. And it talks about this. The rising of temperature decreases the amount of oxygen, and aquatic organisms suffocate and die. If the flow of warm water into a lake or stream is constant, it can cause total disruption of the aquatic ecosystem. Groundwater pollution. This is another pollution that we talk about in terms of water. And this is basically pollutants. So we already have the definition of pollutants. We don't need to redefine that. Pollutants getting into the groundwater. This happens usually through percolation. So as we learned about groundwater, we learned about percolation. And when you have surface water that is polluted with something or for some reason, and that percolates down through the earth's surface, through the different layers, that pollution can then get into the groundwater. And so any pollution of the surface water in an area actually can have an impact on the groundwater in that area. And so what are the types of things, what are the human uses or the human activities that can affect this? The use of pesticides, herbicides, and chemical fertilizers, and petroleum. It's those four that tend to be the most common groundwater pollutants. Somehow, some way, they are what cause groundwater pollution. Okay, this is from human activity. Septic tanks, landfills that aren't lined, industrial wastewater lagoons. People used to literally bury their oil tanks for their homes in their backyard. And if your oil tank sprung a leak or ruptured, just slowly ooze that petroleum. It's going to work its way down to the groundwater. So this all, is real, and it does and it has happened in the past. It says here leaking underground storage tanks. And the problem with these leaking underground storage tanks, guys, is that because it's underground, you don't know it's leaking. You may have one at your house. You know, a house was built 150 years ago. At some point, they put in an oil furnace, they put in an oil tank, and they buried it in the backyard. And you may not even know it's there, because by the time you bought your house, it was on natural gas or electric or whatever, and you don't realize you've got an oil tank that's half full in your backyard that's leaking until it's leaked enough to actually be noticeable. So these are some of the challenges that exist. And what we do with modern storage tanks is we embed them or contain them in concrete. And there's lots of other safety measures that we put in to prevent leaks. And I make that point here, guys, to remember, a lot of this has a point in time. We buried oil tanks, we didn't think about this. Now we know it happens, and we put measures in place to prevent it. So this isn't something that just happens and keeps on happening and continues to happen. This diagram in your textbook, I'm not going to spend a lot of time discussing it, but it shows in a diagrammatic format all the different ways that groundwater pollution takes place and happens. All right, how do we clean up groundwater pollution? Very challenging. You don't just go in, dig down to the groundwater and clean it out. It's already there. Groundwater recharges very slowly. So we're talking many, many, many years for the water that is contaminated in the groundwater supply in an aquifer to be reprocessed and recycled out with pure water. And once pollutants go down, they can actually cling to the rock and cling to the soil and be a part of the aquifer. So even when new, fresh, clean water gets into the aquifer, it may still become polluted from the pollutants that are there from the last pollution event. So, all these make cleaning up groundwater very challenging. Ocean pollution, for years and years, and it still happens, we have pollutants that are just dumped directly into the ocean. Ships can legally dump wastewater and garbage overboard in some parts of the ocean. This isn't across the board, but it's in some parts. And I mentioned this before, at least 85% of ocean pollution, including pollutants such as oil, toxic waste, medical waste, comes from activities on land and near the coasts. So it's human activity here that eventually gets there. And this has an impact on coastal ecosystems, coral reefs, and we see a tremendous amount of effect there. Oil spills. Oil spills tend to make the news. They tend to be big news items. We know that ocean water is polluted by accidental oil spills. 37 million gallons of oil from tanker accidents spilled into the ocean every year. And they have dramatic effects. They make the news. We see coastlines covered in oil and marine life covered in oil. But they only make up a very small percentage of oil pollution. Most of the oil that pollutes the oceans comes from cities and towns. It comes from our activities on land again. This diagram shows some of these. I don't spend a lot of time on this. Water pollution in ecosystems, immediate damage, but we also know that it can be far-reaching. And guys, some of this is kind of, some of this is driven by opinion, some of it's driven by fact. Marine biologists will tell you that the ocean or a water ecosystem, a lake or whatever, it has the ability to clean itself rather quickly, usually more quickly than we tend to think. And I always point to the big issue in the Gulf of Mexico and BP, and there were a couple of years there where the coasts in the Gulf of Mexico were just horrendous. We don't hear that much about it anymore because the ocean has the ability to clean itself, and we have seen that happen. So we do have to have some intelligent, reasonable balance as we discuss these types of things. Biomagnification is the accumulation of pollutants at successive levels of the food chain. So this is the whole, if mercury gets into the little things in the ocean, and there's actually more mercury in the fish because the fish eat those things, and there's more mercury in the penguins because the penguins eat the fish, and there's more mercury in the sea lions because the sea lions eat the penguins, kind of thing. So we see accumulation of concentration increase as you go up the food chain. And it has alarming consequences for organisms at the top. And it's one of the reasons why we generally limit the amount of fish people can eat out of certain bodies of water. Or we make, as a government, we make recommendations as to how much fish people should or should not eat because of the mercury present. This diagram shows this in terms of DDT. In terms of cleaning up water pollution, we have several governmental acts here and legislation. It is not within the scope of this course to know these and learn these, so I'm going to zip through these, and you're not required to know these dates or the names of the acts. This is still on the Clean Water Act, so again, for your own, if you're curious, all these things you can read about them. But again, it's not the scope of this class to go over this legislation.